So I'm Thorsten Höffler from ETH Zurich, and we are here at the PASC16 conference. And with me is Peter Bauer, the Deputy Director of Research at the European Center for Medium Range Weather Forecast. So Peter, this is your first or second PASC conference?
This is actually my second PASC conference. Last year's conference was already very interesting because we just started to introduce the weather and climate topic at this conference. But I really have to say that this year was an incredible increase of diversity, complexity and depth of the covered topics regarding weather and climate, and I think that's a fundamental and great development of the conference.
So one of the strengths of the conference, or the main strength, is the interdisciplinarity between computer science and climate sciences, and also other domain sciences. So how do you see this in your field? How is this developing? How is this helping you to advance your field?
I would say in our field, computing was always very prominent because we run such large problems in terms of what we do in prediction. However, the actual interdisciplinarity between computing science and applied science has not been well developed so far, but because of the emerging problems, because our models get so much more complex, we increase resolution by so much, we really try to cover the Earth system as a whole at these high resolutions. The computational constraints, the constraints coming with the diversity and the volumes of the data are a fundamental limitation, and therefore we have to draw in a lot more computational expertise. And so this intermediate area between applied science and computing science is an area which is probably going to be the game changer for our discipline in the next 10 years.
So this is actually very interesting, because we've seen Mark Senior's keynote on the first day, and he was talking about the developing of computing industry, computing technologies, the end of Moore's law, and where we go to somewhere approximate computing and things like this. And we just had the session on climate science, so the domain-specific session, and we discussed there how to use approximate computing, reduced precision. So how do you see this going to the future? I mean, what are the major changes that you're facing in the production weather forecast for Europe and the world at the end for the next decades?
Well, it's a simple question with a complex answer, of course. Because as you said, it's a production of weather forecasts, and that goes from the ingestion of observational data to creating the initial state, to running the forecast model and dealing with the output data that needs to be disseminated to the users. And all this process has a very strict timeline. And this timeline is never going to change. So we will never be allowed to take more time in producing a forecast because our users need them for emergency warnings and taking actions and these kind of things. So that's a hard variable. And I mentioned before that we're running a lot more complex systems, so we need essentially bigger computers. And so we have to have a much closer ear to the development of the computing architectures that will provide us, hopefully, with that increased capability that we need. But that has implications for us as well. So it's not just taking your model and running it on a bigger computer. It's entirely different computers, entirely different programming models. And it requires that it actually propagates upwards into the science levels. So we need to change our science accordingly as well. So we need to look for different numerical algorithms, different ways of how to deal with data and describe the physical processes in the atmosphere. And that is very challenging because, again, you need that science and that intellectual capability that can deal with both. So you need scientists who are experts in, let's say, convection or fluid dynamics, and at the same time that person needs to understand what computing architecture you have underneath and how best to program it.
Well, that is probably hard to find a single person who is expert in both fields, right? So it may be a better approach to have some kind of mixed team or something like this, which we are trying to establish here at PASC, in the sense that we have the experts in computer science or in high-performance computing together with the experts in the domain sciences. So do you see that you will hire computer scientists in your team, or do you have computer scientists in your team?
We do, actually. This comes back to that quantum leap I mentioned. In order to allow that increase in predictive skill with weather prediction and climate prediction, you need to invest in computing science to make that possible. So the answer to your question is twofold. On the one hand, you have to hire computing scientists who may have backgrounds in engineering or who have optimized jet engines in Formula One cars before, but fundamentally the equations are not too dissimilar what you do with fluid dynamics in the atmosphere. So these people can learn. But you need a forum like PASC where these people talk to each other because they work on different problems in different areas, even in weather and climate. but also you need to talk to the computing scientists that work for companies, that work at HPC centers like CSCS, for example, to understand what their ideas would be if they would apply or like to optimize their knowledge to weather and climate prediction. So you need a bit of both. You need to hire and create that new generation of hybrid scientists, if you wish. At the same time, you need a forum like PASC to enable the conversation and be at the pulse of the time.
Yes, this is exactly what we are about. So next year we will also have a paper track at the PASC conference again, like we had this year for the first time, and we are very much looking forward to your submission in that field. Thank you very much, and see you next year.
See you next year.